When I was younger, I had a big bulky Walkman, and if I wanted to listen to a particular song, I had to look through the entire tape. But now, all I have to do is to look up this menu, and there I have the song I wanted. That's because all the songs with the same artist and album names are arranged together. It is this feature that makes me suspect that the iPod is a chemist's creation. Why am I saying that? Join me for today's episode and I will tell you why. Hello and welcome to the show. Today I will be taking you through the periodicity or the observable repetition of physical properties of elements along the periodic table in terms of atomic radius, ionic radius, ionization enthalpy, electron gain enthalpy or electron affinity, electronegativity. And finally, we will take an in-depth look at probable exam questions. Now, to understand the arrangement of chemical elements in the modern periodic table and the trends of properties it leads to, we have to grasp the dynamics at work inside the atom. If you recall, increased forces of repulsion between electrons diminish the attractive pull of the nucleus, also called actual nuclear charge. This reduced nuclear charge is referred to as effective nuclear charge. Effective nuclear charge is an important concept to understand as it has a direct effect on another crucial parameter in the periodic table, atomic size. Can you imagine how difficult it would be to measure the size of an atom? Not only because of its minuscule size, but also because of the diffused boundaries of an atom. So their size is measured in terms of radii, which is the distance between the nuclei of two adjacent bonded atoms called covalent radii. In case of atoms which are not bonded, van der Waals radii is taken, that is, the distance between nuclei of two atoms barely touching each other. Now if you are asking what does all this have to do with periodic table, then you are also ready to know why I attributed the iPod's sophisticated menu to a chemist. You see, just as songs in an iPod are scientifically arranged according to similar artists and albums, so are chemical elements in the periodic table. In their case, the arrangement is according to similar properties . Let's take a look at the periodic table in terms of atomic radii of various elements. This is a key understanding that you will need to know if you are asked to predict the trends and properties of elements in the exams. So pay close attention. First, the groups. You will see that atomic radius increases from top to bottom. But what happens in a period? The atomic radius decreases on moving from left to right. Lithium is the largest atom in its period, while neon in group 18 is the smallest. Why is this? Time to return to the inside of an atom to find out. We know that the size of an atom is related to effective nuclear charge. When we move down a group, each successive level implies that a further valence shell has been added. This leads to an increase in the force of repulsion between electrons, thus decreasing the effective nuclear charge. This shielding or screening effect of the added shell, which weakens the nuclear charge, leads to an increase in atomic radius. For those of you who may be struggling to understand this, let me give you an example. You know how some students always sit at the back of the class? Well, they are trying to avoid the teacher by using the middle row seats as a shield. Now, if you add an extra row in the middle, they would get even further away from the influence of the teacher. What happens in an atom is just as simple, but things change when we move along a period in the periodic table. For each movement from left to right, an electron is added in the same shell. For every electron added, the nucleus also gains a proton, which increases the overall positive charge of the nucleus. Since the number of electrons remains unchanged in the middle or shielding orbitals, the outermost valence electrons are pulled inwards more strongly. As the effective charge is stronger, the atomic radii decreases. If we go back to our classroom analogy, simply adding more seats to the last row will do nothing to provide an extra shield to our backbenchers, and they will have to come up with other ways to hide from the teacher. Well, whether you are a backbencher or not, I am sure you are ready for this question. Why is the atomic radius of a lithium atom smaller than that of a sodium atom? I am going in for a short break, but see you on the other side with the solution. Welcome back. Before the break, I had asked why the lithium atom was smaller than the sodium atom, and here is the answer. Lithium atom has one less shell than sodium between the nucleus and its valence shell. Therefore, the shielding effect is reduced and it has a smaller atomic radius than that of the sodium atom. Along with atomic radius, we also need to talk about ionic radius, which is defined as the distance up to which the nucleus has an influence over the electrons. Atoms lose electrons to form positively charged cations. The loss of electrons increases the effective nuclear charge. So, the cationic radius is always smaller than its corresponding atom. Example, boron is bigger than boron 3+ ion. Conversely, anions are formed by the addition of electrons to an atom. So the repulsive forces increase and the effective nuclear charge decreases. An example of this is the oxide ion, which is bigger than oxygen atom. So remember, cations are smaller than their parent atoms and anions are larger than their parent atoms. When it comes to remembering the trends of ionic radii, here is an easy trick. Just learn up the trends for atomic radii, as both are similar. Both increase as you go down a group. Why do you think this is? That's right. It is due to the shielding effect of the added shell between the nucleus and the valence shell. And just like the trend displayed by atomic radii across a period, ionic radii too decreases for cations as the nuclear charge increases. Time to take a call from one of our young students who has a very interesting question on ionic radius.
My question is, if ionic radius decreases across a period, then why is a chloride ion bigger than a sodium ion?
Good question. In fact, don't be surprised if you get a similar one in the exams. We know that ionic radius decreases with an increase in nuclear charge. Now, a sodium ion is a cation. Therefore, the effective nuclear charge is more. A chloride ion, on the other hand, is an anion, and the addition of an electron increases the repulsive force, which in turn decreases the nuclear charge, thereby making it larger. The formation of ions is accompanied by enthalpy change. This enthalpy change represents ionization energy, which is the energy required to remove one or more electrons from the outermost shell of an isolated gaseous atom. This ionization energy is also a measure of how strongly the nucleus holds on to its electron. Let's see how this affects trends in the periodic table. When we move down a group, atomic size increases. So, less energy is required to remove the first electron as the valence electrons are farther away from the nucleus. This means that ionization energy decreases down a group. As one goes from left to right in a period atomic radii, decreased effective charge increases and it gets harder to remove an electron. So ionization energy increases across a period. Here is a question that you may get in the exams. Which group of the periodic table shows the highest ionization energy? As you may have deduced from our periodic table image, the answer is group 18 or the inert gases. Ionization energies are all about removing electrons from atoms. But what happens when we add electrons? When one or more electrons are added to an isolated gaseous atom, the change in energy is called electron gain enthalpy or electron affinity. When there is a decrease in the size of atoms, effective nuclear charge increases. This makes it easier for the electrons to be added. So, electron affinity increases with decrease in size of atom. In the periodic table, electron affinity of elements increases across a period due to decrease in atomic radii and increase in nuclear charge. Electron affinity decreases down a group due to increase in atomic size. So what conclusion can we draw from the concepts we have just learned? We can easily say that small atoms add electrons to form negative ions. On the other hand, big atoms lose electrons and form positive ions. But there is a third possible scenario too. There are some atoms which can neither lose nor gain electrons. Such atoms share electrons. If two similar atoms share electrons, the electron pair between the two atoms will be shared equally. What happens if a pair of electrons is shared between dissimilar atoms? In this image, atoms A and B share an electron pair. A is small in size and has stronger nuclear charge than B. Naturally, the pair of electrons will be pulled more towards A. The ability of an atom to attract the shared pair of electrons towards itself is called electronegativity. Here A is more electronegative than B. Now, can you predict trends in the electronegativity of elements? In the periodic table, electronegativity increases across a period due to decrease in atomic radii and increase in nuclear charge. However, it decreases down a group due to increase in atomic radii, which overcomes the effect of increased nuclear charge. Now, in the exams, you may be asked, name the most and the least electronegative element in the periodic table. To answer this, you should know that electronegativity is ranked on a scale of 0 to 4. The most electronegative element known is fluorine with an electronegativity of 4. Francium is the least electronegative element with a value of 0.7. It's time for a short break, but if you want to know more about the type of questions you can expect, then stay with us because we will be right back with Exam Decoded. Welcome back. As promised, we will be telling you how to prepare this topic from the exam point of view. But first, let's do a quick revision of concepts from today's show. Atomic radius increases down a group and decreases across a period. Ionic radius increases down a group and decreases across a period. Ionic size decreases with an increase in nuclear charge. In a period, inert gas elements have highest ionization energy, while alkali metals have least ionization energy. Electron affinity of elements increase across a period and decrease down a group. Electronegativity of elements increase across a period while it decreases down a group. Keep these concepts close at hand. You will need them in the next segment, Exam Decoded. Welcome to Exam Decoded, your handy mate in helping you score top marks. I hope you have revised the basic concepts related to trends of the periodic table, because as always, we will be starting with the rapid fire round. In this round, you will have 5 questions, each for 1 point. I am going to give you 5 seconds to answer each one. At the end of the round, we will tally up your scores and see how you did. Ready? Question number 1. Atomic radius increases down the group. Is this true or false? It is true. Next question. True or false? Half of the distance between the nuclei of 2 non-bonded atoms of adjacent molecules is called van der Waals radius. The answer is true. Your third question is, fill in the blank. Electron gain enthalpy dash A increases down a group, B increases across a period, C remains constant down a group, D remains constant across a period. The correct answer is B. It increases across the period. Your fourth question. Elements in the left group of the periodic table have lower ionization energy than the elements in the groups of the right of the periodic table. True or false? The answer is true. Your final question, and it's an easy one. Which is the most electronegative element amongst the halogens? A. Fluorine, B. Chlorine, C. Iodine, D. Astatine. The answer is fluorine. Time to check your scores. A big congratulations to our perfect scorers, because you are our high flyer. If you scored 4 or 3 points, don't lose heart. You are still an achiever. If you have got less than 3, then that makes you our learner. So, if you need help in improving scores, log on to topperlearning.com, where you will find many other practice tests you can work on. Well, it's not just the periodic table that shows trends, it's also your exam paper. Luckily, while you have been busy studying, we have been busy researching these trends to see how you can achieve the best results. Chapter Periodic Trends in Properties of Elements accounts for 4 marks of the question paper, and so we would rate it important in terms of the preparation time that you should allot to it. Typically, you can expect very short answer type questions of 1 mark or short answer type questions of 3 marks. As far as the ability type of these questions is concerned, we have noticed that knowledge ability type questions are the most frequently asked. In knowledge ability type questions, you will be asked to define atomic radius, ionization energy, electron gain enthalpy, and electronegativity, etc. Or you could be asked about periodicity of elements according to these parameters. Here is a typical question for 3 marks from this chapter. What is electronegativity? Explain its periodic trends. This answer has 3 parts for 1 mark each. First is the definition of electronegativity, which is the ability of an atom to attract the bonded pair of electrons towards itself. Elements with smaller atomic size and higher nuclear charges have higher electronegativity. The next part of the answer addresses two trends, each for 1 mark. Electronegativity of elements increase across a period due to decrease in atomic size and increase in nuclear charge, but they decrease down a group due to increase in atomic size, which overcomes the effect of increased nuclear charge. What other ways can you use to maximize exam scores? Let's find out from today's expert advice.
There is a strong relationship between atomic number and their periodic properties, so learn them thoroughly. You should also know to arrange the elements in the increasing order of their metallic character, atomic size, electronegativity, ionization enthalpy, etc. You should also know to differentiate between electron gain enthalpy and electronegativity.
Now that we have reached the end of the show, I'll sign off with a quote by the very man who created the periodic table, Dmitry Mendeleev, who said, "Nothing from mushrooms to the scientific law can be discovered without looking and trying." So keep striving, keep looking for answers, and of course, keep studying.